I don't usually make content like this, and this took a really long time to edit. So I figured for this last part, after dealing with one corruption and a ton of time realizing that I needed to redo different parts of this because they just hadn't come out right, I'm just gonna sort of speed through this intro and just explain to you that today's tutorial, simply put, is a garage door opener through a cell phone, so a smart garage door opener, hence the title. This should work with any device you have. It'll work with a phone, it'll work with a tablet, it'll work with, different brands, it'll even work with a computer. You just need a stable Wi-Fi connection. And if you want to change that so that you don't need as good a Wi-Fi connection, just put forward this out of your network, maybe add like an encrypted password, and it's a done deal. You just need to make it secure if you decide to open it up to connections outside of your network. Anyhow, we're just going to get into the video pretty quickly. 70 lines, shouldn't be too complicated, but obviously there were a lot of moving parts behind this, so I just hope that you can follow along and that this helps you in some way to achieve your goals with web development, Arduino, whatever you want, maybe a mix of the two. And yeah, that's going to be it. Getting into the hardware itself, you can see what we have here is 2 chips and then some connections. This is an Arduino Uno Rev 3, and you can get these from a number of websites. However, I tend to get them from the official sites just because Amazon's policies with knockoffs are not great, and they tend to get mixed in, so it's a mixed bag if you buy from there, even though it's going to be a little bit cheaper potentially and have better shipping. Anyhow, so getting on to the board itself, what you can see here is that this is basically a rolling garage door opener, and essentially this is where, if you had the case on, you'd be pressing these buttons in order to open and close the various parts of the garage door. However, I have stripped that down. So basically, what you're looking at here is a coin cell slot. The downside is negative, right? So what I did then was I took this side here, which is a ground slot on my Arduino, and I just attached a wire to an alligator clip to the ground, and then I attached that to the corresponding ground on this circuit. Next, I took VIN 5 volts. Well, actually, I didn't use VIN, but for this, it's VIN. So I used 5 volts out from the Arduino and added that to my VIN on this board, which would be right here, anywhere on this side for the coin cell. And then the most important part is right here. So you can see on the back of the board, I have this one little connection, and if I hold it very closely, I would hope that it'll zoom a little bit or adjust. I don't know, it's hard to tell if that's happening. There we go, I made it focus. So you can see this is soldered, and if I flip this over, you can see it corresponds to this button here. Now, this button, contrary to what you might expect, actually has 4 individual nodes here. You can see on the back there are 4 pin places or placements, and so if I were to set something up, I would need to figure out which these correspond to. Now, I happen to know from previous experience that the diagonal pins, so these 2 and these 2, correspond to single direction of flow. So all I really had to do was try all 4 of these pins and then figure out which one corresponded to the output of the button. So essentially, once you press it, it'll allow current to flow through wherever we're connecting it to. So I soldered to here. When you press the button, current flows from this side through the button to this side. So we're basically bypassing the need to use the button. And that saves us a ton of work with manually rewiring the garage door. So now we can plug this back in. I used port 12, and you can see the whole circuit assembled is very compact. requires very little setup, and overall makes this an extremely simple build. Alright, so now we're going to enter the coding phase of this whole tutorial series, and the first thing that we're going to want to code is going to be this Arduino. And getting into this, I'm going to really be working on describing how this is going to operate. And so in order to do that, we're going to go over some key concepts about how we theoretically are going to want to structure this whole thing. So when it comes to creating an application like this, a networked application that utilizes the Internet of Things and connects a device to another device, our key focus is going to be on how we can create that bridge and then communicate, in the simplest terms, information between those two ends points of the bridge. So the one end of the bridge in this case is going to be our Arduino, which I will just plug in right now. And we already went over how the Arduino itself is structured. So now what we need to do is we need to figure out how we're going to connect this Arduino, one, to our computer in a meaningful way, because we're going to use our computer as the wireless component of our server. There we go, it's now connected. And two, how we are going to connect our computer to a web server. So first what we're going to do is we're going to establish a means by which to do the latter. So the web server in theory is going to run through Python, and then the Python is going to communicate with the Arduino. Now we have a way of doing this, and it's very simple, and it's the serial communication of the Arduino. So we can actually communicate through a USB with this Arduino. So for example, if I upload this code to the board, you can see it's just compiling down here, and it should upload any moment now. There we go, it's now uploading, and it's done. So if I click on this serial monitor, you can see it now says ready. And so if I were to type a message, this would be sent to the board, and the board would trigger some kind of event. So you can see in here, what we do then is we can establish a serial connection with these two commands. This part just indicates that the Arduino is connected, and then we can change pin 12. As you saw in the hardware, pin 12 is connected to the essentially the trigger, the output of the button on the garage door opener. And so if we put current through pin 12, we'll be able to actually control our garage door and trigger events with it. Now we go through void loop, and this is just the main loop of our program. So if you work with other programming languages, you know what I mean. It's almost like a while loop, except it's just an indefinite loop automatically triggered by the Arduino. So this is runtime essentially. So when the Arduino begins running this program, it runs this, and then afterwards it runs the following. So what it does is it starts with this in byte value, which we don't actually need. We can remove this. I just didn't really feel like doing it. Anyhow, it begins with an if statement. It checks if there's serial data. If there is serial data available, we begin a while loop for the serial data, and we say serial.read, and what this does is it essentially flushes the serial buffer, and so then we'll have no serial data after this activates, because when we read 1 byte of serial data, that byte is removed from the buffer. And so we go through the entire buffer and just clear it, and then what we do is we use our code. So we send a message back to the serial line, and it says command received, and then we trigger that 12th pin, opening the garage door or closing it, just essentially triggering movement from the garage door. We wait, then we turn it off, and then we wait again, just so that we can't spam it too much to hurt the garage door in some way. So you can make these whatever you want really for the delays, but these are in milliseconds, so this would be half a second and then 1/5 of a second. And that's all we need on this end. Now we're going to get into the next phase. Alright, so now moving on to the actual server side, specifically as opposed to the hardware, and also getting on to the website, so the front end, and sort of, interknitting those two. What we're going to be doing is just working with Flask, which is a framework for Python that allows you to host HTML sites from Python natively. So first what we did was we imported Flask and render template. Render template will allow us to render static HTML pages from files. So you can see in this templates folder we're storing our index.html, which is the main page for the garage door opener. Next, we imported Flask Socket.io, which is a wrapper. It wraps Socket.io around the Flask application and allows you to use its functionality within Python as well. So we instantiate a new Flask app with the running name, and this just is going to be server. Then we set the secret key to key. It can be anything you want, but that's just an arbitrary choice. Since our security is not a big deal here right now. Socket.io equals Socket.io app just wraps Socket.io around the existing Flask app that you saw was instantiated up here. Then we generated this app.route. So what this does is when you load the page, this / will be your default. So this is where you're going to go by default if you load the IP address on which this is being hosted. And so this just routes you to the following page. So what we do is we return the page that we want to load, and in this case I return the render template function, which gets and compiles the static HTML from index.html, which is in the templates folder. That's very important. And it just basically loads this whenever I then call this app.route. Next, this is a message handler. So Socket.io wrapper allows you to take these Socket.io events and on a message event, which would just be using the send command from any other connected socket, we can actually handle the message, right? So that's what this function here does. And then we print the message just for the sake of logging, debugging, etc. Then we send the message back, and we check if the message is our trigger. So that would just be sent as the string trigger. And then if it is trigger, which would mean that a user has actually attempted to click on the garage door, essentially, we write to serial, which would be the serial that we instantiated earlier in this part of runtime, which would be COM4, which just happens to be the garage door opener's, the Arduino's running port on my computer in particular. This would be whatever yours is, with a baud rate of 9,600. And so we write to this any sort of character, just a char in this case of A, and we encode this to raw Unicode. So this needs to be in Unicode because it can only take bytes. It cannot take the actual letter. So you need to make this into a series of encoded bytes that can be transmitted through the serial port. And then we read a line back from the Arduino, because obviously every time we send this to the Arduino, if it receives it, it's set to return command received, and so this will just allow us to verify that everything is working on that end. Then we print out the message that it sent back, and we move on to this now, just explaining this really quickly. All this does is, after our Flask app has been generated, which this should ideally be in here, but for the sake of this I did not put it there, we generate this serial, port for COM4. We read the first line, which is going to be ready from the Arduino. We print that line, and then we just run the app through the socket.io or socket.io command. And this essentially just hosts it 0.0.0.0, just makes it discoverable across the network. So I can then use this computer's IP locally on this entire LAN network. From any other device that's not connected to the computer itself, but rather to our network, and it will be able to connect to this perfectly. And so that's just what that does. It ensures that that all works. And Now, moving on to the front end, essentially what we've done here is we have a basic HTML page. This is nothing special. This has Smart Garage Door as the tab title, and this just makes it easier for, less tech-savvy people to find this and find the bookmark, because this is automatically what this will be named. And then these are just our imports. So we imported the Socket.io wrapper from the following address, and this is not, you can just look this kind of thing up, but basically this isn't something you need to understand. It's just where this pulls the import from for this page itself. Next, I brought in jQuery because I ended up using jQuery here. So in the body, then I created a script, just embedded, and then within this script I generated a document.ready function using jQuery. So when the page is loaded fully, this is called. Then within this running JavaScript, we log ready upon loading, and then create a socket connection with the IP address. So this is my local IP address on this network. You can find this by just doing ipconfig in your command prompt, and then socket.on, basically just this, in this case, we put connect in it, so that means that this whole thing here, this block, will be called whenever we connect to the page. So upon connecting, we send this message to the server, and that indicates that a new connection has been established. At that point, we move on to this part. So this hashtag here, or pound, whatever you like to call it, essentially signals that this is the class ID, or the ID, sorry, not the class, the ID or the tag for the element. So you can see down here we have a toggle ID for this button. So whenever this is clicked, so this on, and then with the click inside, allows us to essentially hijack this button's on-click function. Whenever this button is clicked, we send to this socket through this message format the message trigger. And so as I showed you earlier, that will trigger this whole chain of events. This will send the message to the Arduino. The Arduino will trigger an event on the garage door. So it basically just goes to the back end and routes to the hardware itself. And then obviously we just create a button. I made this button cover the entire page, just so that it would look more aesthetically pleasing on, devices, and also be easier to click. But you can do whatever you want with the stylistic choices of it. It's not supposed to be, amazing or anything. It's just a bare bones site. So I hope that makes sense. Now we're just going to move on to a short demonstration. Alright, so now that you've seen that actual demo on the garage door and you know that it all works, what I'm going to do is just demonstrate somewhere with a better connection how the whole process altogether works, just so you can see the server and the front end and the hardware all at once interacting. So over here, what I'm going to do is I'm just going to go to my Smart Garage directory, so I'm navigated there, and then I'll run my server. I apologize, that's the dog. So what I can do now that I've run this server is I can connect. So you can see over here I have this garage door opener as a bookmark. I can put this in, and I'm now connected. These other connections were because I have some tabs open on various other parts of other devices that are just connecting automatically at the moment. However, if I now click trigger, what it's going to do is it's going to send a message to the back end. So you can see it does that right now, and the command has been received by the Arduino itself. The message came through as well, and what I have here is an LED, and so I've rewired from this garage door remote to the LED. So instead now, if I press this, the LED activates until the delay is ended. So you can see it all works very well, and on this other end it's all being processed in real time. And yeah, that's the gist of it. If I were to reroute this to this garage door opener, and put this pin back into this soldered connection, it would all load through this, and then, it would work the same way, except it would trigger the garage door. So essentially that's all of it, 70 lines. It could be shortened from there even just by removing spacing and removing some unnecessary bits of code that I had from just getting all of the basics set up for this. So if you enjoyed this, remember to leave a like, subscribe, comment, share, etc., etc. You know the drill. And yeah, I hope you enjoyed this. As usual, that's going to be me signing off.